These are the model's guesses for each data point. Each 0 represents a prediction of class 0, and each 1 represents a prediction of class 1. I'll compare these to the actual labels to see how well the model performed. These are the correct classifications for each data point. These are the real answers, and we'll use these to evaluate how accurate the model's predictions were. This statement tells us the model's accuracy, and I'll calculate it in a moment to check if this is correct. I think this statement is true. This is the formula for calculating accuracy. TP stands for true positives, correct positive predictions, and TN stands for true negatives, correct negative predictions. I'll use this formula to check if the 62.5% accuracy is right. This statement means that the accuracy score doesn't care if there are more examples of one class than another. I am calculating the percentage of correct predictions, regardless of whether those correct predictions came from class 0 or class 1. This is a simple statement. A perfect score means every prediction is exactly correct. If my model achieves 100%, this means that there are no mistakes. This is the topic. We're evaluating how well a model does at classifying data into two groups. We're figuring out how well the model predicts class 0 versus class 1. This indicates that I need to calculate accuracy based on how many predictions the model got right. I'm about to use a standard method to figure out the accuracy. This is the question. I'll check each statement against my accuracy calculation. Let's find out which statements are actually true. This problem focuses on how well a binary classification model, a model that predicts one of two outcomes, performs. We'll be using a specific metric, accuracy, to measure this performance. We'll use the _accuracy_score function from the scikit-learn library in Python to calculate the accuracy. Scikit-learn is a powerful library for machine learning. These are the predictions made by our model for 8 different data points. A 0 represents one class and a 1 represents the other. These are the actual, correct classifications for the same 8 data points. If the model gets every prediction right, its accuracy will be 100%. This is the perfect score. It means there were 0 mistakes. I'll need to assess the accuracy of the model using the given predictions and true labels and then determine which statements are correct regarding that accuracy. This is one possible answer for the accuracy of the model. I'll calculate the accuracy to see if this statement is true. This statement shows the formula used to calculate accuracy. Let's break down what true positives, TP, and true negatives, TN, mean and apply the formula. Accuracy is the total number of correct predictions divided by the total number of samples. This statement highlights an important feature of accuracy. It only cares about the number of correct predictions and doesn't take into account how many of each type of prediction, 0 or 1, was correct or incorrect. These are the model's predictions for each data point. 0 represents one class and 1 represents the other class. I see 8 predictions in total. These are the actual, or true, labels for each data point. They tell me what the correct classification should have been. Again, there are 8 data points. This statement says the model's accuracy is 62.5%. I'll need to calculate the accuracy myself to verify this. This statement describes how to calculate accuracy. Accuracy is the percentage of correct predictions. It uses true positives, TP, correctly predicted positive cases, true negatives, TN, correctly predicted negative cases, and the total number of samples. This tells me that accuracy only cares about the number of correct predictions, and doesn't consider whether one class is more frequent than another. Class imbalance. It's a simple metric. A perfect score of 100% means every single prediction was correct, no mistakes. This is just a label indicating the data we're working with. I'm assessing how accurate a model is at classifying things into two groups. Think of it like this. Is a picture a cat or a dog? I'll evaluate how well the model does this task. These are the model's guesses. A 0 means the model thinks it's one type of thing, and a 1 means it thinks it's the other. So, this list shows each prediction one after the other. Let's see how good these guesses are. This is the actual answer key. These are the correct classifications for each item. We'll compare them against the predictions to see how well the model performs. I'm going to test your understanding with a multiple choice question. This question asks you to analyze the statements below and determine which ones are correct regarding model accuracy based on the predictions and true labels. This statement gives a specific accuracy value. I will check if this is correct by manually calculating the accuracy of the model. This statement describes how to calculate accuracy. It says to add the number of times the model was correctly right and correctly wrong, true positives plus true negatives, and then divide by the total number of samples. This statement says that the accuracy only cares about the number of correct answers and does not consider if one type of prediction is more frequent than the other. It's straightforward. This is stating that if the accuracy is 100%, then the model was perfectly correct each time. It made no mistakes in its predictions. I'm evaluating how accurately a model predicts whether something belongs to one of two categories. Think of it like this. I'm testing a model that tries to guess whether an email is spam or not spam. These are the model's guesses. A 0 represents one category, e.g., not spam, and a 1 represents the other, e.g., spam. The model made 8 predictions. These are the correct answers. They tell us whether the model's guesses were right or wrong. Again, a 0 means one category, and a 1 means the other. We have the true class labels for each prediction the model made. I'm asking you a multiple choice question about how to measure the accuracy of the model's predictions. I'm asking you which options correctly describe the accuracy of the model. Accuracy_score is a way we can evaluate our models, using a formula to get a percentage result. This is one possible answer to the question about the model's accuracy. This is a formula to find the accuracy. Let me elaborate. True positives, TP, are the number of times the model correctly predicted a 1, and true negatives, TN, are the number of times the model correctly predicted a 0. Total samples is the total number of predictions. This statement says that accuracy simply counts the correct predictions, and doesn't care if there are more zeros or ones in the data. A score of 100% means the model got every single prediction correct. The word dataset refers to the combined model predictions and the true labels. Both make the dataset. This refers to the model's guesses, which are 0 or 1 for each data point. These are the actual categories for each data point, either 0 or 1. This is a prediction or a true label, indicating one of the two categories. This is a prediction or a true label, indicating one of the two categories. This is a prediction or a true label, indicating one of the two categories. This is a prediction or a true label, indicating one of the two categories. This quiz tests your understanding of how we measure the accuracy of a binary classification model. A binary classification model is one that predicts one of two outcomes. Think of something like spam, not spam email detection. We'll figure out how well the model does by checking its predictions against what actually happened. Pretty straightforward, right? Here are the predictions our model made for 8 different test cases. Each number represents a prediction. 0 means the model predicted one class, e.g., not spam, and 1 means it predicted the other class, e.g., spam. Let's see how it did. These are the actual outcomes for those same 8 test cases, the ground truth. We compare these with the model's predictions to see how many it got right. This is one possible answer to the quiz question. It tells us the percentage of predictions the model got correct. We'll need to calculate the accuracy to see if this statement is true. Let's check the math. This statement describes the formula for calculating accuracy. True positives are the cases where the model correctly predicted a positive result. True negatives are the correct negative predictions. Total samples is simply the total number of predictions made. We divide the number of correct predictions by the total number of predictions. Accuracy counts correct predictions, but ignores whether there's a greater proportion of one class over another. For instance, whether there were more spam or not spam examples doesn't change the accuracy calculation. It's a simple metric but may not be the best in all situations. A perfect 100% accuracy means the model predicted every single instance correctly. Makes sense, right?